Hey guys, welcome to this video on the 2019 Level 2 Probability External Paper. So question 1, Sean is interested in how heavy a student's school bag is. Using a random sample of New Zealand students, he obtained the weight of each student's school bag to the nearest kilogram. The results of his investigation are shown in Figure 1 and in Tables 1 and 2. Question A. Use Table 1 to find the probability that a student randomly chosen from this sample has a school bag weight more than 10 kilograms. So you want to find the probability that x is greater than 10 in this sample. So when it says weighs more than 10, that means it's in this case will be 11 and upwards. So we'll be looking at 11 to 18. So these weight totals. So we're gonna have to add everything up. So we'll say just everything. So 5 plus 4 plus 2 plus 4 plus 1 plus of the 2 plus 1 plus 4 plus 1 plus 2 plus 4. So everything that fits in the 11 to 18 kilogram range. So 5 plus 4 plus 2 that equals to 30. So our total probability will actually be 30 over the total number of students. So the total number of students is 558 plus 413, which is 971. So our probability would be equal to 30 over 971. And that would be a chief level question here. Question II. The probability that a male is chosen with a school bag that is 2 kilograms or less. So our requirement here is the probability of a male chosen which has a school bag of 2 kilograms or less. So probability of a male with a x less than 2. Alright, so we'll be looking at 2 and below, so we'll be looking at 58 and 26. So 58 plus 26. Oh no, sorry, that's the female students part. Sorry, my bad. So I actually be looking at 59 and 24. 59 plus 24 is 83. So 83 over the total number of males, which is 413. So our probability would be it says 2 kilograms or less. Oh no, sorry guys. Sorry. So that's 2 kilograms or less. That's less than or equal to actually. So I have to go back. So that's actually 60 plus 59 plus 24. Sorry about that. So 60 plus 59 plus 24, 143 over 413. So 143 over 413. I'm pretty sure. Double check. Yeah, and that should be another achieved mark here. A heavy school bag is defined as one that weighs over 5 kilograms. Based on Sean's data, the following claims made. Female students in New Zealand are more likely to have a heavy school bag than male students. Does Sean's data provide evidence to support this claim? So we're looking at the weights over 5 kilograms, so from 6 to 18, and we're trying to compare the relative risk of a female having a heavy bag compared to a male having a heavy bag. So our relative risk would be our female students female probability of a female student with x is greater than 5 over the probability of a male student with a bag of x is greater than 5. So once again we have to do some addition, unfortunately. So we're looking from 6 to 18, so that's from 6 to 18 here, which means from all of these numbers and all of these numbers. Okay, so for males, so this is males probability of a male having a bag of more than 5 kilograms would be 30 plus 30 plus 20. Okay, I'm not gonna write it out, but 30 plus, just add everything up in the column. So 30 plus 20 plus 19 plus 6 plus 9 plus 2 plus 1 plus 4 plus 1 plus 2 plus 4. That is 98 over our total, which is 413. So that's our probability of male. And our probability of female would be everything added up in the female column. So 49 plus 32 plus 24 plus 7 plus 13 plus 5 plus 4 plus 2 plus 4 plus 1. and that is 141. So probably the female is 141 over the total, which is 558. So now we can use our relative risk. So we can say that relative risk is equal to, what was it? So 141 over 558. So 141 over 558 over relative risk. So 98 over 413. So 98 over 413. And calculator work here. So 558 divided by 98 divided by 5. So this relative risk comes out to be 1.065. So that will be your relative risk. So basically, females would be 1.065 times more likely to have a heavy school bag compared to a male in this study. So we can write our generalized statement. We could say, according to the study, it is 1.065 times more likely for a female student to have a heavy bag than a male. And the claim was, so female students in New Zealand are more likely to have a heavy school bag than male students. That's a claim. This claim is true because our calculations show that it is more likely for female students to have a heavier bag, as it is 1.06 times 1.065 times more likely. So we can say, in terms of the study, the statement is justified as 1.065 is actually greater than 1. So if the relative risk was equal to 1, that means that the probability of a female having a heavy bag would have been equal to a male having a heavy bag. So if it's more than 1, that means females will be more likely. Hence, the statement is justified in terms of the study. However, if we look at the wider picture, this study only studied about, let's say, 558 plus 413. It only studied 971 students in total. And the claim says that female students in New Zealand are more likely to have a heavy school bag. This generalization is too broad, as you only used 971 participants in New Zealand. That's not enough students to make a generalized claim about the whole of New Zealand. So we could use that as a statistical consideration. So we could say only 971 students were in the study. Hence, the claim for the whole of New Zealand may be unjustified, as the sample size is not very large. Okay, so that could be your statistical consideration, and this should be able to push you up to an excellence for this question. To get a merit, if you have the relative risk correct, that's relative risk as well as the up to here. So from here to here, you'll get a merit. And to get an achieved, you just get the relative risk calculated correctly, you'll get an achieved mark. Before doing this research, Sean expected that the school bag weights would be normally distributed. By referring to the shape of the distributions in Figure 1, describe clearly how these distributions are different from a normal distribution. So in a normal distribution, we know that 50% of the data should lie to the left and the right of the mean. However, if you look at the Figure 1, which is from the study, you can clearly see that the mean should be around 3 to 4, somewhere here. And however, you can see that there's much more data to the right of the... There's much more data to the right of the mean than the left of the mean. So this is definitely not normally distributed, and as well as there's a very strong right skew of the graph. So the shape is something like this. Oh no, sorry. The shape looks something like this, and that is extremely right skewed. A normal distribution should look roughly like a parabola. Okay, so it should look roughly symmetrical. This is very right skewed, so that is definitely not normally distributed. So we can say the shape of the normal distribution should be symmetrical. 50% of data on to both sides of the mean. You can say, however, the figure 1 shows a heavily right skewed so it shows a heavily right skewed graph, as well as there being more data to the right of the mean than the left. So hence it is not normally distributed. Alright, so the shape of the normal distribution should be symmetrical, so 50% of data should be on both sides of the mean. However, on the figure 1 shows that it is heavily right skewed, and there's much more data to the right of the mean than to the left of the mean, so therefore it will not be normally distributed. This is a right skewed graph. So I give 2 reasons why it is unlikely that school bag weights to be normally distributed. So this is 2 reasons. We need 2 reasons. So one reason I can think of straight off the bat is that the study did not account for what year the students were in. So let me double check that. It doesn't say which year. Yeah, it doesn't say which year the students were in. So we could say, for example, that they surveyed an NCEA level 3 student, and they also surveyed some NCEA level 1 students. We could say that the NCEA level 3 student could be carrying, for example, maybe more books because they're studying the courses in more depth. So they might need bigger and larger textbooks, which could increase their total bag weights. For NCEA level 1 students, maybe they would have lower bag weights because they would carry lighter textbooks. So I'll give 2 reasons. That could be our first reason. We could say different year levels, different year levels. So I have different year levels, and that's one reason. And another reason we could talk about could be location could come a part of it as well. Even location. I mean, you might think that location might be irrelevant, but in terms of what I'm thinking right now, so if you're in a very city area, there's actually more shops and more, so it's more industrial, so it's easier to get supplies for school. However, in a rural area, there may be less shops around, so therefore there might be less supplies available. So what I'm thinking is that maybe students in rural areas might have a shorter stationery requirement list, as they might be further away from the shops, and therefore they may have less access to these resources. However, for the schools in the very city populated areas, they may be very close to shops, so they'll have all the stationery requirements, so that could increase their bag weights. So rural area students may have lower bag weights, while urban areas might have higher bag weights. So that could make sense as well. So you could talk about location. What else can you talk about? You can talk about unlikely how school weights would be normally distributed. So, what else can you talk about? You can talk about Yeah, okay, you can talk about yeah, different year levels, location. Like you can talk about the school as well. So even if you talk about the schools, like for example, a school and a, for example, a school maybe. I mean, like different schools, they'll definitely have different supplies, and like like for example, you borrow textbooks at the library. Like for example, a school might have less. Maybe one school will have more textbooks. Maybe a school will have less textbooks, and this also could affect the amount of textbooks that a student is carrying, so the amount of supplies they have. So whether dependent on the school is also an important factor. So that's something you could talk about as well. And is there anything else I can think of? Hmm. I mean, just in general, we could talk about the different students, I guess, because like some students like to carry, have everything close to them, while some students like to carry less things, and then maybe some students like to use the lockers more, while other students might feel it's unsafe to use the lockers, and therefore they may carry more. So that's also a definite argument. So you can say that some students may feel more comfortable to carry more items, so they feel the items are more safe. However, some students could also feel more comfortable to leave their items in lockers, for example, or just leave their items at home. So that could also be a relevant argument actually. So there's actually quite a lot you can talk about here. So you can talk about different year levels. You can talk about the location. You can talk about the different schools, and you can also talk about different types of students that could be affecting the study. So these are the different reasons of why it is very unlikely that school bag weights would be normally distributed. So if you're, for example, if you're going to be talking about one of these, you could say, for example, if you say different year levels, you could say year 13s may be carried more, so hence if more year 13s were surveyed than year 11s, then therefore it will be a tendency to be more higher data, more higher weight data. So this would definitely lead to definitely not a normal distribution. So you can just talk about how if there's an inconsistency about the number of students measured, for example, one group has more students than the other, then that could definitely affect and make it very unlikely for it to be normally distributed. So you can just talk about any two of these reasons, and that should be good enough. So basically, for this question, how I think it's going to work is that these two are combined. Actually, I actually think it may be combined. So if you get both of these questions at a good level, so basically if you get right skewed correctly, and you can also say that it is these two reasons I explained, you could get an excellence grade for this question. In terms of getting a merit, I'm thinking if you just do either one of these, it could be a merit. And so either or could be a merit. So this could be by itself, it's a merit. This by itself is a merit. And to get an achieved, I think you can just do some brief explanations for an achieved. So maybe just one or two lines might get you an achieved. All right, question 2. Actually, I'm going to do question 2 in a separate video. So thank you for watching this question 1 video. I hope you all enjoyed, and I hope to see you on the next one. Thank you. Bye.